So, quiz 4. So remember that when we're declaring an array, we state the number of positions that we want in it. So the lowest position is 0, and the highest position, so lowest valid index would be 0, and the last valid index would be 9. So the position that we specify, minus 1. So write a C statement to create an array called R filled with 20 positions of type float. So remember, we can have arrays of any type in C, so we can say float. So we say our array name. So we have of type float, named array, or named R, with 20 positions. So if I enter 5 here, how many positions will be in the array? So we read 5 into size, and then we do size times equals 3. So I didn't realize this, but people didn't really understand this operator, I don't think. So remember what this does is it takes whatever is in the size variable and it times it by 3 and then stores it back into the size variable. Remember, these are called compound operators, and they all do the same thing. So let's say we had plus equals, it would take size, it would add 3 to it, and it would store it back into size. So again, in this case, what would happen is we'd store 5 into size, we'd times it by 3, which would give us 15, which would give us 15 positions in our array. So we've talked about 2 different ways we can initialize an array to 0 in this class. So let's say we have my array with 10 positions. We can say equals 0. That's the first way we can initialize something to 0. We could also use like a for loop or the init function to initialize it to 0. So we could say init my array has 10 positions, and we want to initialize it to 0. So if you manage to tell me either of those ways to do it, then I gave you full points. I should have at least. If I didn't, then let me know. Yep. Yep. Okay, talk to me after class. Okay, so given this expression, so rand mod 100 plus 10, what's the range of possible numbers generated? So remember that if we had rand mod 100, we would get 0 through 99. So we take, that's our base range, and then from that range we add on 10 after that. So instead of saying 0 through 99, we have 10 through 109. So this first one, the correct answer was ASDF. So in our array we have 10 positions. We set the first position equal to A, second to S, third to D, and fourth to F. And then it would print ASDF. If you told me something about how there was no null terminator in the first position, I still should have given it to you correctly. So if you said ASDF and then just like put garbage or something after that, I should have given you the points. Or if you did like that, I should have given you the points too. So if I'd marked that wrong, let me know. So the name of the last character in a C string used to signify the end of the string. So that's the null terminator. So null terminator. And that is signified with a \0 or just 0. So if you gave me any of these things, I should have marked that correct. So this one, I changed the array indexes around. So to build this, we find 0. So 0 is S, then 1 is F, then 2 is D, and then 3 is A, and then 4, which he wouldn't write, is /0. So that would print out SFDA. So we do the same thing here, except with this one. So we set position 0 equal to S, then 1 equal to F, and 2 equal to D, and then finally 3 equal to A. But then we set the first position equal to the null terminator. So what that's going to do is when we pass into that string, or when we pass R into puts, what's going to happen is it's going to see that null terminator character right away and output nothing. So the correct answer is nothing, or just new line. Something along those lines would have gotten you credit for that. So when we call gets, it will store whatever we input into str and also add a null terminator at the end. So it would be HELLO and then \0 for the null terminator. So what's insecure about the gets function? So remember we talked about it a little bit. So gets will allow the user to input as much as they want. If gets was to be secure, they would need to specify how many characters they would read from the user. So I think it was unlimited input was what was wrong with the gets function. All right. So we also talked about this a little bit. So the difference between gets and fgets is fgets only reads in 10 characters from the user, and it also reads in the new line that the user enters when they press enter. So this would be HELLO, a new line, and then null terminator. So that's quiz 4. Any questions about that? All right. If you think I graded something wrong, let me know. I will take a second look at it. So if you go over to grades, just remember that I did bring down the total number of points on this to 9, just because people didn't do that great on it. So for the remainder of class, gonna talk about assignment 8 really quick, actually. So if you didn't catch on D2L News, I didn't change the text of assignment 8. So I crossed out the part about rewriting assignment 6 in the languages that you select. So instead, I want you to write a program in each language to sum user input. You should read in how many numbers the user will input first, and then read in that many numbers, and then sum the numbers that the user read in. You can sum them right away. You could use an array to store them if you'd like. Do it however you please. So does that description make sense to everybody?
What if we already started rewriting our assignment 6?
If you already have assignment 6 done, just leave it as is. Yep.
So how do we submit the files?
So remember, I want you to make a directory to put all your work in, and then use this zip command to create the zip file, and then submit it using the normal procedures. So you'd use the zip command to make the zip file, and then you'd say submit assignment8.zip. So remember, what I want you to do is inside this assignment 8, I want you to have 3 source code files for your different languages, and then I want to have a single text file just trying to describe the difference between C and each of those languages that you selected. So name it something like, I don't know, assignment8.txt or something, just so I know that it is the description for what you are doing.
So do we put the text file in the zip file?
Yep, put the text file in this assignment 8 folder.
And then zip it all.
Yep, put everything together. All right, so any other questions about assignment 8? Is that going all right?
So like, we get the code together, and I can't seem to figure out how to run my Python. How do we run my, so do I have to run it on my
I think you just, in order to run it, you just have to put Python and then the file name.
What is actually happening?
So like, I wrote out my Python code, and made like the .pyc file, and then it's like, it doesn't actually run.
You don't run the PYC file.
It just said, I tried to look up online, and it's like, make a PYC file, so I did python-m, and that makes sense. So python-m in my assignment file.
Is it print? I think it's print.
is gonna do Python and then the file name.
Yep.
Yeah, makes it complicated.
That's how it is with. That's how this will be with basically everything, except for Java, because Java's dumb. So if you have Python, PHP, Ruby, JavaScript, you'll just have your source code, and then you'll run the interpreter, and then specify your source code as the argument to the interpreter.
And C++ is just C++.
Yep.
It took me a while to figure that out. I couldn't find it anywhere, and then I wonder if I did this. Oh, it does work.
Yep, the entire point of this assignment is to find some interesting things and to learn some new things about different programming languages and just kind of become more used to the environment. So, any questions about assignment 8 other than that?
Rest of the time work time?
What?
You work the rest of the time?
No.
That'd be really nice, actually. Some like one-on-one help whenever I
Okay, so I'm going to cover a couple things really quick. So if you go to Content Week 16, you'll find topics covered in this class. So these should be all of the things that we talked about in this class. And I'm just going to go through them and kind of talk about them. If you have questions about anything at any time, stop me and I can try and clarify them. You should know most of this material for the final. There will be questions about it on the D2L component, and you'll be expected to know how to use these components in the program that you'll write for the final. So, let's start at algorithm and pseudocode. So we talked a little bit about pseudocode in this class. So what pseudocode does is it describes how you would solve the problem, but doesn't actually provide the source code for the programming language that you're working in to solve the problem. So it allows us to represent difficult things that take a lot of effort to do in C in simpler terms. So why are we learning to program in C, or why have we learned to program in C, I should say. So C is a humongous language. There's a very large install base. Many computers are based on C. Basically every single operating system that exists is written in C. C is a very fast language, and it allows us to understand how the computer is running as opposed to just implementing the logic. So when we're writing in C, we're very close to the hardware level. So basically everything that we do in C is a native operation that the computer can actually run. When we're looking at higher level languages, like a couple of like Python, like Ruby, like that, they abstract away a lot of things and they make things very simple, but at the same time, they don't allow us to gain an understanding of how the computer is actually functioning. So we started off by writing a hello world program. So we just said print puts hello world, did we? Here, I'll bring this over here. Yeah, we just said something like puts hello world. And what that did is it outputted hello world. And I should say put. So, editor, we use Nano to write our programs in. I also used Vim to edit things too, but there's a couple other different editors on command line system. All you got to remember is that to edit a file, you'd say your command, and then you'd say file name. So, compiler. So what a compiler does is it takes your source code and it generates machine code that the computer can run. So remember that we said GCC and then file name, and that generated a.out. If we want to change that, we need to say GCC file name. We say -o to specify the executable that we're generating. So we say my program, and that generates my program. So remember, we use the -o flag to change the output from the compiler. So again, what the compiler does, this is the GNU C compiler, so that will take a C source code and generate the machine code needed to execute that program. So when I say machine code, I mean the actual instructions that the computer executes at a very low level to execute your program. So this is one C compiler. There's many different C compilers that you can use. GCC is probably the most popular one. If, let's say, you were on a Microsoft Windows platform, you would use cl.exe to compile. If you were on an OS X platform, I believe you'd use llvm. Not things that you need to know, but just good for reference. Let's say you wanted to compile some C++ source code. It's very much like the C compiler, but instead of saying GCC, so GNU C compiler, this is the GNU C++ compiler. So same syntax, file name, etc. So that's compiler. So variable, so all a variable does is it's a named piece of memory that we can store things into. So at the very basic levels, we need to specify, or to declare a variable, we need to specify what type of variable we want and the name of it. So we could specify int, char, float, double. I think that's all the variables we've talked about. Is that all the variables we've talked about? Any other ones? No.
What is double?
We can talk about that in a bit. And then var name. And then a semicolon to finish the line. So if you wanted a variable, you'd say int, my int, and then you can use that variable throughout your code. And what that does is it creates a location in memory that we can store things into and retrieve things from. So in data type, and just remember an integer is a whole number. That's basically all you need to know. So expressions and operators. So you need to know that these operators right here are called arithmetic operators. So we can add, subtract, multiply, divide. Let's say we have our variable called myInt. I would say myInt equals 10 plus 10. I could say something like that. I could also specify a variable name instead of a literal number. I could specify as many things as I want to, though. I can chain as many things as I want to using arithmetic operators. All that matters is that there's a variable on the left, equal sign in the middle, and an expression on the right. So this is something we call an expression. So it's built with literal numbers. So this is what we call a literal number. It has a value. It never changes. So 10 always has the value 10. And variables. So we can build an expression by saying any number of things over on the right here with addition and everything. So let's say we had a function called getInt, which read a single integer from the user. We can also specify a function as a part of our expression if we wanted to. So just keep that in mind. So output with printf. Remember that when we say printf, we specify the first component being a string. So when we say string in C, that's just something surrounded by two quotes, or two double quotes. And then inside this first component, which is called the format string, we specify format identifiers. So I will write some code here to output myInt. So I'll say myInt is and %d, and then we'll say myInt. So what this will do, printf will go through this string. It will look for any format identifiers. So remember, a format identifier starts with %, and then whatever data type we're looking at. So it'll look for any format identifiers, and then it will look after the comma for that variable, and it will replace that format identifier with this variable. So this will output myInt is, we'll say it's 10. We'll set it up to 10 here. So remember that this doesn't have any new lines, so in order to get a new line in our terminal, we need to say /n. So that would take our terminal output and it would bring it down a new line. So remember, a new line is a \n. You should also probably understand format specifiers. So remember that we can say, let's say we had a float called my float, so equal to 10.10. What we can do is say %f in my float. And by default, how many decimal places will that print out? Yep, that will print 6 by default. So that will say 10.12345 And remember, to control that, what we need to do is put a format identifier, or a format specifier, I should say, in between the % and the f. So if I put 0.2, then we would output 10.10. Read up on format specifiers if you don't remember. So just to review, this is the format string right here. This is the format identifier. And this is the precision specifier is what I should say. I said format specifier earlier. I meant to say precision specifier. So that specifies how many decimal points to the right that we want to print. So that's output with printf. So we'll talk about scanf next. So remember, in order to read in, we can say scanf, and then we specify the variables that we want to read into. So if I have a single d, I need to say an ampersand my int, and that will read into my int. So we can also specify multiple variables of multiple different types. We can also say %f over here, and we can read into my float at the same time. We can build as many, we can put as many identifiers as we want into the scanf here. One behavior that I don't think I talked about a lot with the scanf is when we have a single space here, that's not necessarily a literal single space. So if I was to input something like this, if I was to say 10 and have a bunch of spaces like this, and then 11.11, so this will still properly read in 10 to my int, and it will still properly read in 11.11 to my float. So not something you need to know, but something that you keep in mind. So scanf is pretty straightforward. Remember that if we're reading in a character, one of the things that might happen is when we press enter, that new line character that we press enter to is stored as a character. So we might have to do the %c twice if we want to read in properly. So the first time we read %c, we might get a new line, so we might need to read it a second time. So just remember that a new line would be read as a character as well. So floating point values, talked about that a little bit. Talk about compound operators. So one of the reasons compound operators exist is because we would end up writing things like this a lot. My int equals my int plus 3. And what compound operators allow us to do is remove this component of it and imply that we're going to add 3 directly to my int. So my int plus equals 3. So there's also, that's addition. You can also use subtraction, multiplication, and division. So you could say my int equals my int times 3. Instead of saying that, you could say my int times equals 3. You could also do subtraction and division. So there's also increment and decrement operators. So remember, you can do minus minus my int to decrement it by 1. You could do plus plus my int to increment it by 1. And you can also put those operators on either side. They do have different meanings, but for this class, that's all you'll need to know. So, if statements. So remember that when we're writing an if statement, we say if, we say condition, and then we have a body down here. So if this condition resolves to true, so true is equivalent to non-zero also, remember? So if it's 0, then it will be false. If you specify, okay, let's go back a little bit. So again, we specify a condition here. If it's true, we execute the statements inside the block. So if, let's say, we could do a condition like this, and we could say 1 equals to 1, and that condition will always be true, and it will always execute. We could invert that. We could say not equal to 1. That will never be true. It will never execute. Remember, we can use variable names in here too. That's completely valid. My int. And we can string conditions together with something like this. Or so what would you, what does this operator mean? So if either of these conditions are true, then the statement body will execute. So what does this one mean? And, yep. So what do we call those classes of operators? The and, the double ampersand, the or, the double bar. Yep, they are I think they're logical operators. Yep, they are logical operators. So, and then there's also not to negate the sense of a condition. So let's say we had, we'd set my int equal to 10. So remember, non-zero is true and 0 is false. But we could also negate that condition and say not my int. So by default, we can specify my int here, and if it has a non-zero value, this will execute. But if we want to switch that around and have it only execute the body of the statement when my int is 0, then we could say not. And what this is read as not. So the exclamation point is also part of the logical operators. So we can also chain ifs together. We can say if, we can say else if, specifying another condition. And we can say else, which is our final condition. So if this condition is true, this condition right here is true, this statement will be executed and we'll go down to line 48. Otherwise, we'll test if this condition is true. If it is, we'll execute this block. If it's not, then we'll execute this block. So we can chain as many if statements together as you want. We can have a single if statement. We can have a setup like this. We can have if, else if, else if, else if. We can have if, else. We can have as many as we want. We can chain them together as many times as we want. The only conditions are there can only be one opening if, and there can only be one else. You can't specify multiple else blocks because that wouldn't make sense. So that's if statements. So math with the modulus operator, remember that we can get the remainder of a number by specifying mod. So let's say I said, or get the remainder from a division operation using mod. So let's say I said my int equals 10, and then I said my int mod 3. So what would this statement, or what would this expression return?
1.
Yeah, because we would take my int divided by 3. That would give us 9. And this would give us 1. So remember that when we're dividing integers in C, we're going to drop the remainder off of the integer. So if I was to take 10 and divide it by 3, it would give us something like, what is it, 9? Or no, it wouldn't give us 9, sorry. It'd give us 3. It'd give us 3, 3, 3. It'd give us 3 repeating. What am I thinking? But since we're working in C, the integer would truncate the decimal. It won't round it. If it's 3.9, it will still truncate the decimal and round down to 3. Just so remember, so divide and mod are very, very similar. Yeah. So loops, for, while, do. So the setups we have The most basic loop is, of course, the while loop. So we specify a condition here. And while that condition is true, we're going to execute these statements inside the block. So let's say we start off with my int equal to 0, and our condition is my int less than 10, and then inside here we increment my int by 1. Let's have some fun. Let's print some stars. I know you all like stars so much. How many stars is this going to print? Go fish. It's going to print 10, yep. So let's say we change the condition up. How many is this going to print? That's going to print 11. Yep, because what's going to happen is we're going to start at 0, so the first time we run around, my int is going to be 0. We're going to increment it by 1, so let's go back to our original expression. So I'll track my int down here. So it's 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, and then finally it's going to be equal to 10, but this is no longer going to be true, so we're not going to run at that time. So we count up how the different values of my int. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And for each of these values, we outputted 1 star. So let's say we change this condition around a little bit and said plus equals 2. So instead of incrementing by 1, we increment it by 2. So let's go ahead and let's just track the values for my int that will keep the expression to be true. So we have 0, we have 2, we have 4, we have 6, we have 8, and that's it. Because after that we hit 10, so we only have 1, 2, 3, 4, 5 stars that are printed off. So those are the valid values of my int that will allow this expression to be true. So you should be able to do that. You should be able to track what a variable is equal to and how it's modified, and determine whether or not the body of a statement will be executed. So that was the while loop. So that tests the condition, remember? It tests the condition first, it then executes the body, and then it goes back to test the condition, executes the body, tests the condition, and so on and so forth. So we also have the do while loop. So we have do, and we say while. So the only difference between the do while loop and the while loop is we execute the body of the statement one time first, regardless of what the condition is, before we test the condition. So instead of testing the condition and executing the body, we instead execute the body and test the condition. And then if the condition's true, then we go back and we execute the body again.
What happens if you like do and then a statement and then don't have while?
You're required to have a statement, or you're required to have a while.
Okay.
Yep, it will not compile. And then remember, our final loop was the for loop. So we need to specify. Okay, so very basic for loop. We say for, and what will this do? Can anybody tell me what this does? Yep.
Well, it executes a statement. First off, the first one allows you to set a variable or do something like that. The next part of it is conditions. Then afterwards, you can set it to do something like add to a variable or something.
Yep. So these are the 3 different components of our for loop. So remember that if we don't specify any of these conditions, that for loop is going to run forever. So remember, we can use break inside our for loop to exit it. We can use continue to stop executing any of the statements and continue on. Remember, the execution order of our for loop is, it should be set and then test condition, execute statements. I think this is the right order. I might be wrong with increment, but increment 5 go to 2. Go to 6. I think that's the right. But check the PowerPoints if you don't believe me. So that's our for loop. We can do a bunch of tricky stuff, but since we're running short on time, I'm going to go over that. So big one that we still need to talk about is functions. So remember, a function is a named reusable piece of code that we can store statements into and do lots of stuff like that. So remember that the way we specify a function is return type, function name, and then any parameters. And then the statements that we want executed. So remember that if we specify a return type, let's say we say int, then inside this function we need to use the return keyword to return a number. If we say, we could say return float, we could say 10.10, but if we say void, void again remember means that the function doesn't return anything, so we can just say return, but we cannot give it any data to actually return. So remember, for parameters, we can pass in parameters by specifying the data type and the parameter name. And then by calling this function, we would say fun, let's say 1011. So that will take the value 10, it will store it in A, it will take the value 11, it will store it in B, and then you can use these inside the body of your code. So you could say A plus B, or you could say return A plus B, and say we're going to return an int. So that's functions. Remember, we can call functions inside other functions. So we could do a bunch of other stuff. Don't have time to talk about all of it, though. So we talked a little bit about, we've talked about all this stuff at the end here more recently. But any other questions about the stuff on this list? Anything else you want me to talk about or cover? Do you remember that you should understand all of this content, and if not just for the final, for 250? Because if you're going on to 250 semester after this, you will be expected to know all of this content to do well in 250. So if you do have, if you don't understand this content, you should definitely take the time to understand it. If you don't understand it for the final in this class, you should at least take some time out of your Christmas break to figure out how it works. So any other questions? This is the last time we'll meet for this class, so speak now or forever hold your peace.
One thing I don't know about the get stuff.
Yeah, yeah, it's not that important. I probably won't have much on it. Maybe I uploaded the PowerPoint, I don't remember. If I have it, it's here. Maybe I never actually uploaded it. I will upload that really quick though. But that's something you'll talk much more about in 250.
So do we come here for our final one?
Yep, the final should be in this room.
And it's Friday?
Yes. I don't know where it got off to. Here it is. It's day 33. Yep, so you take a look at day 33. I did talk very briefly about gets and fgetS. Some examples, a little bit of a narrative about why gets is unsafe. Anything else? This week's really busy for me. I'll probably be able to respond to an email, but I can't schedule any time to sit down this week. I'm just too busy with crap. So that's all for class today. Again, if you have any questions, I'll be around for the next 5 or 6 minutes. Talk about